Um, Welcome back, guys, to our YouTube page. So this is Group 34 at the Quad, and we're presenting a project called Swift Service. I think we'll go on to the problem and the investigation. So we discovered a huge research gap when it comes to the impact of people understanding the meaning of traffic signs in relation to the number of road accidents on the road. This most likely occurs with inexperienced or novice drivers. So we did a background study on this, and we discovered that of recent, with the development of smart cars and self-driving cars, it has created the need for detection and recognition of traffic signs, because these things need to understand how to move and how to relate with the normal road situation in real time. So people would use algorithms like KNets, LNet, CNN models, the GABA protest scanner, and optimizer techniques. So here, like you're seeing in the slides, for example, the proposed technique for traffic sign recognition is evaluated using the German traffic recognition benchmark. They used these data sets and this technique, mainly this in Germany, and according to the methods they used and the machine learning algorithms they used, it gave them an accuracy of 99%. Though, through this simulation that they did, we actually saw that there was an area for improvement, and we actually saw that we could do more. So moving on to the study significance, what we hope our research will do is that we hope it will assist drivers in driving and make driving more convenient. That's one of the problems. So under significance, we're going to have driver assistance programs. Of course, this is mainly for the drivers, and the main goal is to make the process of identification or swift or detecting an identification swift and easier for them. Another significance or another application or influence from this research could be highway maintenance. So we could currently use these videos or detectors to be able to do work which would have been done manually by humans way more easily and faster, because these signs are detected easily by the model. Then this research could actually help us improve on the AI systems that are used in self-driving cars, and that's the impact our research could have, and we hope it to have. So under the research scope, geographically, we want to investigate the performance of our model with road signs around Kampala. So under research scope for the geographical part, we are limiting it to the central business district of Kampala. Theoretically, in terms of software, we want to use YOLO V3 image datasets, and the machine learning algorithms will limit ourselves to our convolutional neural networks and natural language processing, and also use natural language processing in machine learning. Why? Because our model is going to mainly be dealing with image processing and human comprehension to understand the language of humans as another human would. So maybe I would also say what we will not go into is that our implementation will only consist of a camera to detect signs while in a car, but we will not, for now, we will only consider the permanent installation for car systems as future works because of the resources at hand. we can only implement this with a camera in a car. So, okay, a good number of novice drivers on the road in Uganda are either ignorant about the meaning of road signs or oblivious to their meaning, in case in recent studies. Okay, so we identified this problem and the causes and where everything comes from. And we discovered that some of these public entities, which have a lot of loopholes and are incompetent, have a part to play in this, because people are using improper channels and are not getting the proper training that they're supposed to get when going through this to get their permits. And we really think that sensitization for traffic signs isn't really done thoroughly, or this isn't done enough. So what are the research questions? We want to ask ourselves, firstly, what does the presence of road signs impact on the number of accidents? If we have more road signs, will the number of accidents decrease? That's one of the research questions. Do novice drivers know how to use and interpret road signs? Are people trained or sensitized about the significance of road signs? Now, each of these questions is meant to help us to get a base from where to gather our information from, to how our research is going to be and how it's going to impact our project. So we came up with a hypothesis of whether a model for novice drivers or inexperienced road users that detects, processes, and interprets traffic signs from images, recordings, and in real time can reduce accidents and make driving more convenient. That's our hypothesis. Then move on. Research objectives. We want to make driving more convenient and comfortable. We want our model to recognize, detect, and interpret road signs for drivers. And ultimately, we want to reduce accidents. So we move on to the Gantt chart. We have come up with a Gantt chart for the numerous parts of our process of and how long it will take. And this is in months and how each and everything will go on. So for this, there is not much to explain. I'll move on to the methodology. So our methodology will include the requirements process, where we gather the requirements we need in terms of software and hardware analysis. We conduct how we will go about to achieving our goal or using what resources we have at hand. Then design, we'll go on to design this project, and we'll come up with frameworks and different templates to do this. Then ultimately we'll do the coding, the testing, and implementation. So the references, the different references we've used, and these are the research papers we've got online, and we've included the authors and the papers as well. I'll go on to the next slide. Let me see. We'll go on to the next slide for acknowledgements. Okay, so these are as well the references with the links in there as well. So we acknowledge some of the various sites that we got this information from. One was FreeCodeCamp, another was Fantech Solutions, especially for machine learning. We also put down a YouTube channel that we used to get some of our instructions from. And we also acknowledged a certain author who I felt whose paper was really informative and descriptive about deep learning and neural networks as well. And yeah, that marks the end of our presentation. Thank you.